All right, while everybody's getting settled and we've got our presentation up, I would like to introduce our final presenter for this morning in this room. We have Molly Alves. She is a wildlife biologist for the Tulalip Tribes of Washington, where she has worked for over 8 years to protect and restore treaty reserved subsistence resources. Unfortunately for her other job responsibilities, she dedicates most of her time and passion to salmon recovery via beaver relocation as manager of the Tulalip Beaver Project. Beginning this August, she will build on this work as a master's student at Utah State University, where she will be studying the global policies and practices surrounding beaver relocation and management.
Well, good morning, everyone. My name is Molly Alves. I'm a wildlife biologist for the Tulalip Tribes of Washington, and my primary job in this position is to maintain the subsistence resources of the Tulalip tribal members. So anything that they hunt or fish, it is my job to ensure that populations of those species are happy and healthy out on the landscape. And the most culturally significant of these species to the tribes is, of course, the salmon. So I am, very happy to be here today to explain a little bit more about how and why we are partnering with beavers to restore hydrological function for salmon within the Tulalip tribe's ancestral territory. So I want to start off with a little origin story because our project came about in a relatively unique way. We started the project in 2014 as a kind of new, creative, less expensive way of addressing salmon decline on a landscape scale. And to understand how that resulted in a tribe becoming the first Western Washington beaver relocators, there's a few key elements of our program that I want to explain a little bit more about. The first and most important is sovereignty. Tulalip is a federally recognized tribe. And so when this work began in 2014, it was illegal to relocate beavers in Western Washington under a piece of legislation called the Washington State Beaver Bill. So we were at the time and are still to this day operating under the sovereign rights of the tribe to restore and create salmon habitat within the tribe's ceded territory. And that ceded territory is essentially all of the lands that were forfeited by the tribes when they were placed on reservations at the signing of the treaty. The tribes maintain hunting and fishing rights and co-management responsibilities within this territory. So that is where we can do restoration partnering with beavers. Within this ceded territory lies the Mount Baker Snoqualmie National Forest, and the Tulalip tribes have a long-standing memorandum of agreement with the Forest Service to co-manage their lands for those restoration purposes. So under this existing agreement, they agreed to be the recipients of our relocated beavers. Now, fast forward a couple of years, we've been relocating beavers, things are going great, and we started getting a lot of regional recognition, primarily from landowners that wish to have beaver issues resolved non-lethally. So we started getting calls from every corner of Western Washington and realized that we had a major capacity problem. So initially we started reaching out to some of the other sovereign tribes in the area to see if they were interested in training with us and starting their own programs. We were very successful with the Cowlitz tribe in southwestern Washington, who are now in their 4th year of a relocation program. But at the same time, we didn't really want the time-consuming and potentially financial burden of beaver relocation to fall solely on sovereign tribes. And at the same time, we were communicating with a number of non-tribal groups that really wanted to get involved in this work. So in 2017, we decided to attempt to amend that Washington State Beaver Bill. And so we started working with our Tulalip lobbyists. We were able to gather bipartisan support and help them change the language of that bill to include Western Washington. We went and we testified in the State House and Senate. And later that year, the law was successfully passed, legalizing beaver relocation statewide. Yay. And so as a result of that legislative change, the Washington Department of Fish and Wildlife was tasked with creating a pilot program to certify new beaver relocators. And we have a Washington State Beaver Working Group. And so the members of that group contributed to the formation of this program. And we are now happy to be in the 4th year of that program, where we are co-hosting their annual trainings and providing technical training to their new permittees. And then kind of the final aspect of our program is just the programmatic function. I mean, our first step is we really want to reduce lethal management of beavers, but we also want to relocate these beavers to places where they will not only be tolerated, but their dam building capabilities will be respected for the benefits that they provide to our struggling hydrology. So we've all heard this song and dance before. We know that humans have created quite the predicament out on our landscape. What we did when we removed these keystone species from the landscape is we lost immeasurable acreage of wetlands. Our streams became warmer and more eroded. And at the same time in the lowlands, we converted our floodplains into farmland, and we installed infrastructure at a time when beavers were largely absent from the landscape. So as beavers are starting to make a triumphant return to these lowland areas, there's little tolerance for their dam building in now human-dominated regions. This intolerance has resulted in less salmon in our streams and less resistance to disturbances like wildfires and climate change. Fortunately, we have a lot of the people in this room and their resources to combat some of these issues. And we have a partner that works for a fraction of the time and cost of most human engineered restoration projects. Beavers are making a return, like I said, to a portion of their historic range. And we've been studying the effects of these beaver dams. These organic creations we know are good at restoring stream function. They capture sediment, they attenuate peak flows, they recharge aquifers, and have the capacity to increase fire breaks. So we have 3 main research objectives on the project. And the first, when we started in 2014, was to determine if there was even a need for relocation. Beavers are by no means an imperiled species, but the salmon that depend on their habitat are. So we're targeting the Stillaguamish and Snohomish watersheds in Washington State, which are the 2 top salmon producing watersheds to Puget Sound. These watersheds are characterized by flashy flows, disastrous erosion, but first we had to figure out if and where beavers already existed in these areas. So yeah, we have really no idea how many beavers exist. What we do know is that in 2000 in Washington State, body gripping and leg hold traps were outlawed. And as a result, and due to a lack of really a good idea of other management alternatives at the time, beavers started returning in droves to lowland areas, and they were being lethally managed at an unprecedented rate. So since the Tulalip tribes were trying to come up with a creative, cheap way of restoring habitat, we thought, great, we'll just preclude the lethal management of these beavers and move them somewhere else. So we looked to the upland areas within the ceded territory on Forest Service land and tried to figure out if there were portions of the beavers' historic range that they were struggling to naturally recolonize. We developed a 3-step system for identifying potential relocation sites. The first is using the Beaver Intrinsic Potential Model, which was originally developed by Michael Pollock and Dr. Benjamin Dibrenner. And so this model inputs watershed scale metrics like stream gradient, valley bottom width, and it identifies stream segments on the landscape that have the potential suitability for beaver occupancy and dam building. The model ranks these sites from being highly suitable to not suitable at all. And from there, we take those high to medium suitability sites and we go out and we walk them. And we have a site scorecard that helps us further rank those sites on the ground for things like water availability, food availability, anything that's going to make a beaver happy and healthy. And then the final step of our site selection is that each of our sites is vetted by U.S. Forest Service staff to ensure that our relocated beavers won't cause problems to park infrastructure. So when we first started the project, we were focusing in the Snohomish watershed, and from the model, we identified 91 sites that ranked as high or medium suitability, and we went out and we walked all of those sites. And what we found was that of those 91 sites, about 75% of the habitat was suitable for beavers, but was unoccupied by beavers naturally. And so that led us to believe that there must be some sort of barrier, whether physical or ecological, that was preventing them from recolonizing that portion of their historic range, and that there was indeed a need for some sort of assisted recolonization of these areas. And today we have expanded this effort to include 3 watersheds in our region. So now we knew where the beavers were going to go, but we had to figure out where they were going to come from. And we had no interest in relocating just any beavers. So we started to form partnerships with local counties and nonprofit organizations to identify sources of these nuisance beavers. And you will notice I put air quotes around nuisance. I know Barbara talked about this morning. Beavers are a native species, and in and of themselves, they are a natural process, and we are returning them to natural areas. The problem is that they are returning to areas that have been heavily altered by humans, these unnatural systems. So beavers just doing what beavers do are getting themselves into trouble and causing conflict with human values. In agricultural lowland areas, beavers have the ability to build what we consider to be high top dams in irrigation ditches, which can impede salmon passage. And they love culverts. They come up to a culvert in about 86% of Seattle streams and find basically a beaver dam with a tiny hole in it that's really easy to manipulate with just a couple of sticks. So there's a lot of home flooding, road flooding, you name it, they flood it. So we began trapping these nuisance beavers from these human-dominated areas. And I really want to emphasize here that we are strictly removing beavers that are either causing a safety issue or are not providing an ecological benefit. For example, when beavers are trapped in over-engineered detention ponds or highway ditches. We work with, again, the counties and nonprofits to work with road maintenance crews that are battling roadway flooding or farmers that are losing crops or homes. And from there, we do a site assessment with every landowner that gives us a call or that is referred to us. And first and foremost, we want to figure out if beavers are actually causing the problem. But 2, we want to see if in-place or coexistence management is possible before we move on to the potential of relocation. We do education with the landowners and try to convince them that the beavers are just as valuable on their properties as they are where we're proposing to put them. And in cases where in-place management is possible, we work with Elisa from Beavers Northwest. Beavers Northwest is a nonprofit that specializes in these in-place management installations like exclusion fencing and pond levelers. But there are definitely some site-specific cases where it's just not possible to coexist with beavers. So in those cases, we go to relocation. And when we relocate, we are targeting entire family groups or mated pairs. Beavers form extremely tight-knit familial bonds, and we've found over the years that they're far more likely to stay where we put them if we move them all together as a family. So from the traps, the beavers are transported to the Tulalip Fish Hatchery, where they await the relocation and for us to trap the rest of their family members. And here they stay in hatchery raceways with flowing water and constructed lodges. It's very cozy. And to date, we've transported over 200 beavers through these methods. And these are wild animals being returned to wild places. So at all costs, we try to reduce handling and minimize habituation. But there is some information that we need from these beavers when they come to our facility. So each beaver, we take their weight, we determine their gender. They get an identification ear tag, which not only helps us identify individuals while they're under our care, but they also aid in post-relocation monitoring with our game camera trapping. And then finally, we take a hair sample. And if any of you were at Sean's presentation, you'll know about this program. We're also partnering with Washington State University to try and figure out if these DNA samples can be used with eDNA technology to determine, one, where beavers are going after we relocate them, but also if they have the capacity to spread disease or aquatic invasives to these areas. Results are pending. So from the hatchery, beavers are loaded into transport cages with their family members and trucked up to these pre-selected mountain streams. And we are relocating specifically within the same watershed that the beavers were captured. So with the hopes of reducing some of those potential spreads of disease and aquatic invasives. We set up game cameras to monitor their post-relocation activity and anxiously wait for them to build dams. And beavers certainly don't always stay where we put them. That's the biggest question I always get. On average, we calculate around a 40 to 45% retention rate at our pre-selected monitored sites. However, within the past 2 years alone, we've had about 75% retention at our relocation sites, which is excellent. But when beavers do emigrate from these sites, we don't have a really good idea of what's happening to them. We get very little sign of predation within our relocation sites, and beavers are just really difficult to track given their anatomy and the abrasiveness of their semi-aquatic environments. So we hope, our hope or assumption, I guess, is that at least a certain amount of these beavers are remaining in the uplands when they abandon our sites and are continuing to contribute to the genetic diversity of the local beaver populations and increasing climate change resilience. So beaver relocation is definitely not a one-size-fits-all approach to beaver or land management. There are a lot of challenges. The first and probably most glaring is funding. All of our work is grant funded, and while we've been really successful of obtaining a diverse array of funding sources over the years, a lot of these funds are meant to fund one-time projects with really clear-cut deliverables. And as a project that defines success as highly mobile animals staying exactly where we put them, and as a project that has developed into a more long-term program upon which many landowners rely, we often struggle to meet our 3 objectives on an annual basis. And on top of that, a lot of these funding sources don't supply funding for monitoring, which is a huge part of defining success of this work. So yeah, it's also not a one-person job. We rely on grant funding for capacity building to carry out this work. So in an effort to simplify our work and save on staff time, we've transitioned to a lot of new tech sources like using tablets and apps for data collection and management. And rather than spending weeks GPS mapping the wetted edge of our habitats, we now use drones to do aerial image surveys of pre and post relocation monitoring work. Another big challenge is the human dimension. There are still many misconceptions of beavers, and in the areas where they're returning, there's still a surprising lack of knowledge of the benefits that beavers provide. Before our project gained reputation, it was actually pretty difficult to find landowners that didn't prefer lethal management. And so the other thing is that humans can cause disturbance at our relocation sites where we're placing beavers in close proximity to roads or trails. There's a lot of recreational activity, and we don't know to what degree recreational trapping has had an effect on establishment success, though we have had in the past 8 years, 2 beaver families lethally removed from relocation sites. And then the final biggest challenge that we feel is out of our control is climate change. There are sites that we've been monitoring since 2014 that no longer maintain the aquatic capacity to relocate beavers to those sites. So in an effort to try and prep those sites for relocation, we've started to experiment with the use of BDAs. But when we do have funding for monitoring, we want to figure out what's going on with these beavers. So there's a number of metrics that we used to study on the project when we had more resources, but today we are focusing a lot on surface water increase and storage and kind of using that as a catalyst for a lot of the unforeseen benefits on the site. Early on in our work, we contributed to more in-depth hydrologic studies. And for the first 4 years on our project, Dr. Benjamin Dibrenner studied the hydrologic impact of our relocated beavers. And he was interested in seeing if beaver dams impacted things like stream flow, temperature, and groundwater storage. And what he found was actually pretty impressive and astonishing. On average, our beaver relocation sites stored 22 times more surface water than non-relocation control sites. And on top of that, these sites stored 2.4 times more groundwater than visible surface water. And my favorite fact about it is that below these beaver relocation sites, below the newly constructed dams, stream temperature was 2.3 degrees Celsius cooler than above the new complexes, which is pretty substantial. So to give you an example of what these relocations translate to on the ground, I want to show you our site called Mahoney. This is an aerial imagery, and the polygon that you see represents baseline or pre-relocation conditions. And when we found this site, it was a relatively incised stream with a single age closed canopy riparian zone. And it struggled to retain water year round. And so in 2015, we placed a family of 4 beavers here. And to our excitement, they started to build dams. We were very excited. And then we went to check on them the next spring and they were gone. And we were left scratching our heads trying to figure out how to kind of capture what the beavers had started here. And so we decided to supplement this site with new beavers in the hopes that they would build off of the previous beavers' work. And so the following year, we placed a family of 6 beavers here. And not only did they maintain the previous beavers dams, but they built a network of nearly 12 dams on site, reconnecting historic channels that we didn't even know were there, creating a large productive wetland and increasing the aquatic habitat by nearly 3 acres. And within just 1 year, we had spawning and rearing salmon returning to this site. And here's just a photo series of what this site looks like on the ground. This summer was pre-relocation. You can see this channel spanning log, which has now become the backbone of a dam that averages 3 feet in height and is well over 100 feet in length. And this series of dams now provides incredible rearing habitat. And here's just a few other examples of this habitat mapping work that we're doing with drones and GIS. All of these sites were done in the same year and account for almost 11 acres of increased surface water storage at these sites. And not only salmon benefits, but we've seen all shapes and sizes of Washington wildlife returning to these areas where our beavers are building dams. I mentioned we monitor these sites heavily with game cameras, and we use them for about a year prior to any relocation to get a sense of baseline conditions at the site. And often we don't get a whole lot of activity on these cameras, but after we relocate the beavers and they start changing the habitat, we're seeing these localized explosions of biodiversity, which has by far been my favorite part as a wildlife biologist. So to start summing it up, you know, nearly 80% of Washington's wildlife rely on the cooler, cleaner, and deeper fresh water that beaver dams provide. And when allowed to remain in place or strategically relocated, beavers create and maintain wetlands on a really broad geographic scale. Beavers are way more cost-effective and efficient ecosystem engineers than us and should be considered our partners in restoration. And these beaver dams are storing, cooling, cleaning, and slowing fresh water, which isn't just good for fish, but all wildlife and also us humans. And then finally, what's a presentation without a shameless plug? I wanted to bring to everyone's attention some new research that I'm going to be involved in. I was recently accepted to Utah State University for a master's program. Thank you. Working with the incredible Dr. Emily Fairfax and Dr. Julie Young. And the reason that I'm telling you this is because I want to solicit all of you for information. So I'll be studying the the policy and practices of beaver relocation on a global scale in the effort to create a scientific how-to guide of sorts for existing and future beaver management practitioners. So I want to talk to all experts in the field of beaver policy and relocation across the US, Canada, and the UK. So for the rest of the conference, please feel free to come find me. You can contact me at the email address below. And I also have it on the next slide, I think. Yes, perfect. So yeah, thank you guys so much for listening today. Thanks to my project team, our collaborators, our funders, and come find me.
Are there any questions for Molly?
Nice job, Molly.
Thanks, Alexa.
Rather than a question, I'd love for you to share the work you've done beyond bringing the Cowlitz tribe into this, but in California. And I've just been so inspired by your outreach with other tribes. So feel free to share that.
Yeah, and that's a huge impetus for this research, because as many people in this room who may have tried to get into beaver relocation, there isn't really a go-to place to get all of the information that you need to get started. So, you know, Alexa knows this as well. When people want to get involved, they just kind of cold call us and say, teach me how to do what you do. So that's starting to grow exponentially, particularly in the arid West and California, where there's hopefully some legislation getting passed today. But yeah, we've just kind of spent a lot of our free time just training whoever wants to come train with us, whether it's just a phone call or providing us folks with our procedures, or inviting them up to come spend a week in the field with us and learn the technical skills necessary to do a relocation project.
Thanks, Molly. Great job.
Thank you.
Could you go back to the slide with all the camera trap photos and tell us what those animals are?
Oh gosh, yeah. Right there, those are mountain goats. That blew our minds. Yeah, they were passing through one of our relocation sites. We've got an otter, we've got a black bear, coyote, a bunch of, I think those are mergansers. We've had deer, eagles, bobcats, herons, and lots of cougars. But fortunately, the beavers are creating their aquatic escape cover, so they don't often get removed by these predators, even though they're utilizing the habitat that they create, which is great. Yeah.
I have another question too,
Yeah.
which might be a stupid question. Are you ever worried about running out of sites to put new beavers on? What's the status of that?
Absolutely. In fact, that's kind of the hope. We're trying to put ourselves out of business. Yeah, there's never going to be a shortage of beaver issues, and that's why we really try to encourage coexistence before relocation. In the Snohomish watershed, where we started this work initially, we are beginning to reach a stage where we either have to go further out to less easily accessible areas, basically where it would be a pain in the butt to carry beavers. But the hope is that, you know, in the long run, these beavers will establish and start reproducing and kind of do the recolonization on their own. So the only reason that this program is still kicking is because we've incrementally been expanding the geographic scope of our project to encompass new watersheds in the area. Any other questions?
You said that about 75% of some of the beaver area that you wanted to go to needed some sort of assistance to make it better for them. I was just curious what that actually looked like. And you mentioned something called a BDA. I don't know what that means.
Okay, sorry. Yeah, so when we're looking for a habitat, we want to find habitat that beavers will want to stay in, of course, but we also are looking for sites that kind of meet the bare minimum requirements of that, because we want the beavers to restore these areas. So we don't want to put them in like the prime beaver habitat, because that doesn't need any help. But yeah, so we're looking for plentiful water sources, tons of food availability in terms of alder, willow, that's right up near the wetted edge, that's easily accessible to the beavers. We want root wads where beavers can hide out under. But the biggest factor is really just enough water so that beavers have that aquatic escape cover, because that's where they're going to feel safe from predators. And then BDA is called a beaver dam analog. It's essentially, let's go back to that photo. Okay, great. Yeah, sorry. So many acronyms.
All right, this is, I think this will be our last question, unless, Molly, if you want to hang out for a little
Oh,
bit, because
sure.
right after this. is
Oh,
a
yeah, I can
lunch.
hang out.
But we'll take one more question on the mic.
Great job, Molly.
Thank you, Skip.
If you are moving beavers in the spring and early summer, do you check to make sure you aren't leaving kits behind?
Absolutely.
And how do you do that?
Yeah, so we are trapping strictly from around beginning of June, this time to around early October. And the reason that we start when we do is we want to wait until the kits are weaned off of the female and are coming out of the natal lodge so that we know we're able to capture all family members in a single effort. And then we stop trapping in early October-ish, basically because a lot of these sites are at high elevations and we get snowed out. So we want to give the beavers enough time to establish before heavy snows come.
All right, well, thanks so much, Molly.